You think the cloud is weightless. Somewhere out there, nowhere in particular, your whole life just floats. Here's the truth they sold you a metaphor to hide. The cloud is the most physical thing you'll touch all day. It's a windowless building the size of a stadium. And right now, to keep from melting, it is drinking millions of gallons of water. So what does the cloud actually cost? Not the metaphor, the building. Start with what's really there. When you upload a photo, send an email, stream a film, it doesn't go up. It goes sideways, down a cable, into a building like this one. A hyperscale data center. Inside tens of thousands of computers that never sleep, never dim, never stop. We're going to cost out one of these buildings, a standard modern unit, about 100 megawatts of computing power. And that one phrase, 100 megawatts, is where the illusion starts to crack. Because 100 megawatts isn't an internet measurement. It's a city measurement. That's the electrical draw of a small city, running through one anonymous shed that most people will never see, to keep something they think is weightless in the air. So where does the money actually go? Start with the check to put one of these in the ground. A hyperscale building isn't priced like a building. It's priced by power, by how many megawatts of computing it can feed and cool. And the going rate is brutal, roughly $11 million for every single megawatt, just for the shell, the power, and the cooling. That's over $1 billion before a single computer is switched on. Then you fill it. The servers, the storage, the networking, and in the age of artificial intelligence, that hardware has become staggeringly expensive, close to another $9 million per megawatt. Add the land, the permits, the substations. One building, fully fitted, around $2 billion. And once it's built, it is hungrier than almost anything humans make. Those 100 megawatts of computers can't run alone. Cooling and power losses push the real draw to around 120 megawatts. Continuously. Day and night. Every day of the year. Do the arithmetic, and one building swallows around 1 billion kilowatt hours a year. That is the annual electricity of roughly 5,000 homes, a small city's worth of power, for one shed. The power bill alone about $74 million a year. While 400 is natural pause. But electricity is just the loudest cost. There's the hardware itself, quietly dying. Servers are replaced every 3 to 5 years. An endless, rolling refresh that, with maintenance and spares, runs to well over $100 million a year. There's connectivity, security, insurance, local taxes, another 30-odd million. And then the strangest line on the whole budget, the people. A $2 billion building, drawing the power of a city run by a skeleton crew. Often only a couple of hundred people on site. That's the deal automation makes. The labor didn't vanish. It was designed out, so the building could be almost empty and almost silent, and still run the lives of millions. Which brings us to the one cost the metaphor was built to hide. All that electricity becomes heat. 120 megawatts of it. Enough to cook the building from the inside in minutes. So how do you cool a small city's worth of computers, cheaply? You don't use more electricity. You use water. You let it evaporate, and the heat leaves with it. It's brilliant, it's cheap, and it is thirsty beyond belief. A building like this can drink around 1.5 million gallons of water. Not a month. A day. Over a year, that's around 550 million gallons, evaporated into the sky. To keep your weightless files cool. 2030's natural pause. So add it up. Around $2 billion to build. And then, every year, to keep it alive 4 million in electricity. Over 100 million in hardware and maintenance. 30 million in everything else. The small crew and the water. But here is the trap. And it's the whole point of this channel. Look at the water as a bill, and it's almost nothing. Maybe $5 million a year. Trivial. Easy to ignore. Easy to leave off the brochure. Now look at it as a resource. 550 million gallons. From one building. The dollar cost was never where the real cost was hiding. 550 million gallons a year is roughly the drinking water for a town of 14,000 people. For a year. Or, if you want to see it, more than 800 Olympic swimming pools evaporated into the air to cool one building. And the power, that small city of electricity, for a building with no windows, no crowds, a few dozen staff that you will almost certainly never visit. The cloud isn't somewhere out there. It's here. It's heavy. And it's thirsty. That's the hidden cost of the cloud. Not a server. Not a screen. A windowless building that drinks 500 million gallons of water a year, so that the most physical thing you own can keep pretending to be weightless. Every photo you've ever put in the cloud is sitting in a shed somewhere, being cooled by evaporating water. The metaphor floats. The building sweats. That's what we do here. We find the bill that isn't on the receipt. For the things you were sure had no cost at all. You were told the cloud was made of air. It's made of concrete, copper, and water, millions of gallons of it, leaving in a cloud of steam. Next time, what does it cost to keep a single satellite alive over your head? And why the most expensive thing in orbit is the empty space around it.